Good morning andi ela unnaru. Today we are going to discuss about optics. What is the meaning of optics? So optics is a branch of physics. Mainly we are going to discuss about properties of light, and optics is further classified into two types. One is ray optics, another one is wave optics. And here ray optics is also known as geometrical optics, and wave optics is also known as physical optics. So then where is the main difference between these two branches of optics? So mainly under ray optics, to study the properties of light, here the light is treated as a ray. But in wave optics, to study the properties of light, light is treated as a wave. Let's find. Then what are the properties of light? So the light is having seven properties. What are the seven properties? Rectilinear propagation, reflection, refraction, diffraction, interference, polarization, and photoelectric effect. These are the seven properties of light. Let's see what is the first one. Rectilinear propagation. What is the meaning of rectilinear propagation here? The light travels in a straight line unless it is reflected by a polishing surface or the medium of propagation is changed. It means that what? Very simple, Nana. The light travels in a straight line. So initially how the light will travel? In a straight line. So when the light is traveling in a straight line, it should be continue in the same way. Up to what limit? Suppose if you are going to place any boundary surface in the propagation of light, then what happened? Light should be bounces back. That's why they mention one condition here in the definition. Let's see that condition. The light travels in a straight line unless it is reflected by a polishing surface or medium of propagation is changed. Suppose if the medium will change or any other polished surface you are keeping while the light is traveling, the direction of light will changes unless it should be continue in a same straight line. That is the meaning of rectilinear propagation of light. Okay, is it clear all of you? Yes. Now what is the second one, Nana? Reflection. Reflection. What is the meaning of reflection? Shall we discuss about the reflection now? Yeah. So let's see here. Reflection. So reflection is the one of the second property of light. Then what is the meaning of this? When a light ray enters into a, here I am going to take one polishing surface. If the light is if the light is incident on this polishing surface, it should be reflects into the same medium. Again, from this point of instance, we should draw one normal. Why we can draw the normal? Yeah, for to finding of incident angle and reflected angle. So again, if the incident ray, here I means what? Incident ray. R means reflected ray. N means normal. So if the incident ray is making some angle theta with the normal, let's understand clearly about this. Here what I am saying, Nana. So if the incident ray is making some angle theta with this normal, that is known as an incident angle, and reflected ray making some angle theta with this normal is known as reflecting angle. Okay, so if the same incident ray making some angle theta with this boundary surface is known as angle of glancing. Suppose if we extend this incident ray, the angle should be present between extension of incident ray to reflected ray is known as deviation angle. Okay, then how can you give the definition of reflection? So the coming back of light into the same medium. Very simple. When a light is incident on a surface, it should be reflected into the same medium. Ante, it means that the light is incident on the medium and it should be reflected into the same medium. This property of light is known as reflection. Then coming to the diagram, Nana. What is the meaning of I? Incident angle or reflected angle. N means normal. Angle of I in the sense incident angle. Angle of R in the sense reflecting angle. Alpha in the sense glancing. D in the sense deviation. I in the sense incident ray. R in the sense reflected ray. Okay, na? These are the meanings in the terms in the diagram. Meanings of the terms in the diagram. Let's find. Now see, Emma. So we have two laws of reflection. We have two laws of reflection. Then what are the two laws? So what happens if the reflection phenomena will take place? So when the reflection phenomena takes place, let's see the diagram, Nana. So we are taking simply one boundary surface. If the light is incident on a boundary surface, it should be reflecting, right? This is incident ray, this is reflected ray. So when the reflection phenomena is going on, some portion of light is absorbed by this boundary surface. How much amount of light is incident on a boundary? Some portion of light is absorbed by this boundary surface. And some portion of light is turning back. Some portion of light is turning back. Okay. So the remaining portion of light will be enters into the same medium while we are taking a transparent. If we take a transparent medium, then only it will enter. Otherwise it won't enter. Okay. So this is about the reflection. And where the reflection takes place, the surface from which reflection takes place, that is known as a reflector. So here in this surface the reflection phenomena is going on. So this surface is known as a reflector. Okay, let's find. All of you understand up to here? Yes, very good. Next, coming to the last, Nana. We are having two laws of reflection. The first one is angle of I is equals to angle of R. Angle of I is equals to angle of R. It means incident angle must be equals to reflected angle. You can take any surface. Maybe it is a smooth surface or curved surface or any surface if you can take. When the reflection is going on, compulsory angle of incidence must be equals to angle of reflection for any surfaces, for smooth surfaces or curved surfaces. And the second law of reflection is incident ray, reflected ray and normal should be lie on a same plane. So I in the sense incident ray, R in the sense reflected ray, N in the sense normal. So incident ray, reflected ray and normal should be lie on a same plane. These are the two laws of reflection. Okay, let's find. Suppose for example, I am going to give one example based on this small concept, Nana. Suppose here I am taking one boundary surface. The ray is falling on a surface and this is the normal and this is incident ray and it is making some angle theta 30 degrees with the normal. Here my question is, what is the reflecting angle? What is the glancing angle? What is the deviation angle? How can you find? As per laws of reflection, easily we can say that angle of incidence is equals to angle of reflection. That's why angle of reflection is equals to 30 degrees. Easily we can say that. Then what is about this glancing and deviation? How can you find, Nana? Let's see the diagram once again. So if the ray is incidence like this is the normal, this is the incident ray. What is the angle here? 30, right? So if this incident ray is making some angle theta with this boundary surface, that angle we should known as the glancing. And here incident angle and glancing angle both are complementary angles. Both are complementary angles. So what is the meaning of complementary angles, Nana? It means sum of the two angles is equals to 90 degrees. So then if we want to find the angle of glancing, simply we should take this formula, 90 minus angle of I. 90 minus angle of I. With the help of that formula we can find angle of glancing. Now how can we find the deviation angle here? So what is this? Reflected ray. Reflected ray making some angle theta with normal is known as reflecting angle. As per laws of reflection, angle of incidence equals to angle of reflection. Here already incident angle given, Nana, that is 30. Then what about the reflection? That is also 30. Right? Let's see. So deviation in the sense, what is the meaning here? The extension of incident ray. If we extend the incident ray like this, and extension of incident ray to reflected ray, what is the complete angle is there? That complete angle is known as the deviation. Then how to find the deviation angle? Very simple. 180 minus 2 into angle of I, or 180 minus 2 into angle of R we should take. Any one of the formula we can use, ma. Okay, na? With the help of this formula we can find the deviation angle. So as per these two formulas, so what is the angle of glancing here? 90 minus 30, it becomes 60 degrees. Then what is the deviation, Nana? 180 minus 2 into 30, so it becomes 120 degrees. Like that we should find easily. But here also I am going to give one more example. Suppose if the ray is incidence through normal. If the ray is incidence through normal. Very important, ma. Very important, ma. Let's see. One more example based on reflection concept. One more example. What is that? Let's see this diagram, all of you. Actually this is the normal, Nana. The light is incidence through the normal. Okay. My question is, what is angle of incidence? What is angle of reflection? What is angle of glancing? What is angle of deviation? All these things you have to say. What is the question I given? The ray is incidence through normal on a surface. Normally on a boundary surface. What is the angle of incidence, angle of reflection, angle of glancing, and deviation? How can we solve? What is the meaning of angle of incidence, Nana? Incident ray making some angle theta with the normal is known as incident angle. Am I correct or not? Let's see this diagram. Incident ray and normal both are in the same line. Then what is the angle of incidence here? 0. So as per the laws of reflection, if the angle of incidence is 0, what is the angle of reflection? 0. Then how can you find the angle of glancing? 90 minus angle of phi. So 90 minus 0, it becomes 90 degrees. Like that, how can you find the deviation, Nana? 180 minus 2 into angle of I or angle of R. Suppose I am taking angle of I. So then what happened? 180 minus 0, it becomes 180 degrees. Very important. Okay. Like that we should find the angles of the incident angle, reflected angle, glancing angle, and deviation angle. Very simple phenomenon, and mainly under reflection you have to remember how to find angle of glancing, how to find angle of deviation. Mostly the reflection phenomena we can observe in a smooth surfaces or curved surfaces. Loss is same. Okay. So whatever the mirrors we are using in our houses, in that mirror also we can observe reflection phenomena. Okay na? This is the second property of light, nana. This is about the second property of light, reflection. So very simple and very easy. Okay, and tomorrow class the continuation topic I'm going to discuss with you. Okay. Mm, thank you all. We'll meet you on tomorrow. Thank you. If you like this channel, please subscribe it for continuation updates. Thank you all. Thank you so much.